All right, let's take a look at how you would solve these algebraically. So the steps that you would follow are listed in your notes so you can read through those. So step number 1 is to make sure that there is a 0 on one side of your inequality. So you want everything on one side. You have to check that first. So the example number 4, that is set to go. What you want to do next is find those critical values. Find the vertical asymptote, or there could be more than one. Find those x-intercepts and find those holes if there are any. So let's find the vertical asymptote first. We're going to set the denominator equal to 0. It happens to be a quadratic, so we know we're going to have to factor it. Difference of 2 squares is our factoring case. So little x plus 1 times x minus 1. You want to set each factor equal to 0. And when you go and plot these on your number line, a vertical asymptote is always an open circle. So on your number line at -1 and +1, you would plot an opened circle. Vertical asymptotes are always open circles, always, on every single day that ends in a y. Next critical value is to find those x-intercepts, those zeros you can call them. So set the numerator equal to 0 and solve for x. So x plus 3, set it equal to 0, get x by itself. Now you need to look at the inequality symbol, and that's how you know whether to do an opened or a closed circle here. Because the inequality symbol in the problem is just greater than, that is why you would just do an open circle for the 0, the x-intercept. Now, if you remember from when we did polynomial inequalities, we then tested a point in each of the regions. We want to do exactly that. You can draw those vertical lines to kind of chop up your number line. And so I have 1, 2, 3, 4 regions. So I need to plug in 4 numbers, and I'm looking to see if that region is positive or negative. So I'm going to plug in -4. So just be really careful with your integers. Go slow, handle the numerator, handle the denominator, and then bring it together. -4 plus 3 would give me a negative number. -4 squared is 16 minus 1 is a positive number. Negative divided by a positive is negative. So on the number line in that region, I'm going to label it with negative symbols. Test the next region. I'm going to plug in -2. I plug -2 into the function right here. So -2 plus 3 is positive. -2 squared is 4, and 4 minus 1 is positive, and a positive divided by a positive is positive. So I can label that region with plus symbols, plus signs. In the next region, I'm going to plug in 0. I love when I can plug in 0. So you're going to have 0 plus 3, which is positive, and then 0 minus 1 is negative. And a positive divided by a negative is negative. The last region to test is right here. I'm going to plug in 2. So on the top, 2 plus 3 is positive. 2 squared minus 1 also gives me a positive number. And a positive divided by a positive is positive. Now this problem wanted to know where is the function greater than 0. If you're greater than 0, you are positive. So I want to highlight on the number line where I had positive numbers. So I'm going to take my highlighter and I'll highlight this region right here. So from -3 to 1, and then from 1 to positive infinity. So take your highlighter, you're highlighting the solution. When I write my answer in interval notation, I would go left to right. Open circles mean you'll have parentheses. So I would have parenthesis -3, comma -1, parenthesis, and then union, because you have more than one piece, parenthesis 1, comma infinity. And that is your solution. How you could use your graphing calculator to assist and to like confirm, this would want to know where your graph is above the x-axis. So that's where, if you're a more visual person, you can kind of use that, the graphing calculator, to kind of confirm what you think. All right.